Okay, welcome to the next session from Julia. She will talk about autonomous networks and how to reach them through APIs and AI agents. Welcome.
Hi everyone, and thanks for taking the time to join this session. My name is Julia, and in today's sessions, we will talk about how we can evolve from an automated network that is focused on network planning into an autonomous network planning using APIs and AI agents. So the topics that we will cover today, we will start by reviewing the different types of AIs and what value they can bring into the business. Then we will talk about some background information on network planning with Crosswork Planning and its predictive AI capabilities. Then we will talk about the powerful Crosswork Planning APIs. Next, we will talk about some of the challenges that still exist today and what are the new opportunities that we foresee in order to introduce autonomy into our automated process using agentic AI. And finally, the conclusion of the session. So when we talk about artificial intelligence, most likely the first type that comes to our mind is generative AI. Generative AI helps to improve service delivery and increase customer satisfaction. How? By allowing the AI models or LLMs to learn patterns like human languages or programming languages, and then will help us to create new content. But this is not the only type of AI. We have also other types of AI, like for example, predictive AI and agentic AI. Predictive AI will help the business to make better decisions based on analysis of data. So it will predict future outcomes by analyzing some data. And then we have agentic AI that will help the business to reduce cost and improve efficiency. How? By allowing the autonomous agents to interact with our tools, and based on that interaction, then adapt through the interactions, and then help us to execute different tasks. So our session will focus on these two, the predictive AI and the agentic AI. So now let's talk a bit about the background information on network planning. So Crosswork Planning is part of the Crosswork Automation Suite and is here to help you to simplify your network design, your network planning, and your network optimization. One of the main characteristics in Crosswork Planning is the predictive AI capabilities. So Crosswork Planning will help you to predict the impact in your network in case of network changes, in case of network failures, in case of traffic growth, if new services are added, and so on. And then the multiple tools that Crosswork Planning offers can be categorized in modeling, simulation, and forecasting that will leverage the measured and simulated traffic for accurate predictions, and also optimization tools that will optimize your network design and will provide suggestions and recommendations that you can apply in your network in order to optimize your design. But so how Crosswork Planning works? It all starts by building the network model. The network model should be a faithful representation of your actual network. So it means that we require to have a digital twin of your network. So then network modeling is the foundation of AIOps, and it's also the foundation for what Crosswork Planning does. Crosswork Planning offers an extensive and also an extensible abstracted network model, multi-vendor network model, and the key here is to abstract as much as possible. Crosswork Planning has its own Crosswork Planning collector with multiple inbuilt collector tools that will gather the data directly from the network and then will abstract it and will build the network model. But it also has a few offline tools that can help to build the model offline, and it also has its powerful APIs that can help to build you the model from scratch or to extend the network model in order to support some particular use cases. So now, let's see a quick demo on Crosswork Planning using the predictive AI capabilities. So here we can see the Crosswork Planning design UI where we can visualize our network model. So we can select objects in the network model and Crosswork Planning will represent them in the map plot. For example, if we select a demand, Crosswork Planning will show the routing path of that specific demand. So for my first predictive scenario, I want to see how my network will look like in case of traffic growth. So for example, I will select all my demands and then will apply one specific value of percentage that I plan to increase. So once I execute the network, it will produce the updated model where we can visualize how my network will look like after the traffic growth. For example, we have this link with orange color that is representing a utilization between 80 and 90%. In this case, in particular, 85%. So now that I increase my traffic in the network, I want to see how my network will behave in case of failure scenarios. So for that, for example, I can execute this simulation analysis tool that will programmatically execute failures across the network, and then we produce a detailed report showing to us the utilization after the failures. For example, 2% of the failures in this case would cause the interface utilization to exceed 100%. It also produced this new visualization, the worst case visualization, where we can see, for example, that we have one link showing red color that is representing that in the worst case scenario, it will exceed the 100% of utilization. And we can find also what is the specific failure that would originate that this specific link exceed the 100% by executing the fail to worst case scenario. We can see Crosswork Planning now is representing the specific failure that originated the other link to exceed 100%. So now that we already executed the traffic growth, we already executed the simulation analysis to see how my network will behave under failure scenarios, I want to see how can I optimize my network, right? So in order to optimize the network, Crosswork Planning offers multiple optimization tools. For this demo, I will use the IGP metric optimization, and I will tell to the tool I want that the utilization of my interfaces to be under 60% in normal conditions and under 80% under failure conditions. So then I will also tell to the tool to produce a new network model, because later I also want to compare my optimized model with the original model. So once the tool is executed, then it produces this new model, the optimized model. It produces also a detailed report where we will find the suggestions or the recommendations that we need to apply in our network in order to optimize our network design, to rebalance the traffic. And it also produces, in the new model, it has a new visualization where we can see all the links are showing green color, that in this case is meaning that the utilization is is under 50%. And then we can also run again the simulation analysis tool on top of our optimized network to see how it will look like under failure scenarios. And in this case, we can see that it is totally optimized. So we basically, 0% of failure would cause the interface utilization to exceed 100%. So these are some of the optimization tools, simulation tools that we can execute in Crosswork Planning, native tools. We can, of course, execute manually, step by step. But now, for example, let's say we may need to build a custom network planning workflow and then automate it. Or as we mentioned earlier, for example, we may need to extend our network model in order to support particular use cases. How can we do that? We can do that by using the Crosswork Planning APIs. So basically, we can take our network planning to the next level and supercharge it using the Crosswork Planning APIs. So some of the common use cases when we use the Crosswork Planning APIs are we can extend and augment the network model. We can create custom network planning workflows and then automate them. We can access to the simulation results and then do some post-processing that we may need. And as with many other platforms, we can also use the APIs to integrate with external platforms. So now, let me ask you a quick question. Please raise your hand if you are familiar with Python. Okay, good. So everybody familiar with Python? That's good. And we also have some good news, because it really doesn't matter if you are starting in your Python journey or if you have advanced experience. Why? Because Crosswork Planning offers these high-level Pythonic APIs. We have two Python API libraries. The first one is the optimization and prediction module, also known as the OPM Python API libraries. And the main characteristic of this API is that it has an intuitive Pythonic syntax. You can see in the example below how a user can create a single LSP through the UI step by step, click by click. And then we have the equivalent to the right side. This is a snippet of a code using the OPM API. So basically, it's only a few lines of code and using a very high-level Pythonic syntax. And then this OPM API is a wrapper of another API that is called Design RPC API. This Design RPC API is a very native API. It has access to every single attribute in the model and also to every tool available in Crosswork Planning. A few characteristics of this API is that it requires connection, client-server connection. It uses an RPC mechanism. And when we codify using this API, we need to take into account that we will use managers in order to access the objects, and then the objects are composed of multiple attributes. So when we execute the scripts using the APIs, we can use that through the UI. That's OK. but there may be some use cases where we require to run the scripts externally, outside of the Crosswork Planning VM. So for that, Crosswork Planning offers this Crosswork Planning SDK, which is actually a package containing the design and OPM libraries that will allow the user to write and execute the scripts using the APIs outside of the Crosswork Planning VM. All we need is a Linux instance running some specific versions of Python. And then also the connection between the SDK client and the Crosswork Planning VM will be secure by using the TLS protocol. So now let's see a couple of examples, 2 Python scripts. One of them, the first one will be using the OPM API. So I will use this sample model, which is the US1 sample model. And the objective for this Python script will be to calculate the details of the routing path in case if I add a new demand in my network, for example, between Seattle and Miami. So the main step that we need to do is to import the OPM library. Then we can start reading our arguments, for example, the input plan file, the source and destination node of my demand, the corresponding traffic, and then using the with statement, we can access to the plan file by passing the corresponding arguments, like for example, the Crosswork Planning details. And if we want to access to each of the objects, we need simply to use the dot notation, simply Python syntax. So then once we access to the object, we can start using the different operations, like for example, calculate the route simulation and then get the shortest path from that new route. Then we can get, for example, all the interfaces across that route. And then we can access to every single interface in the interface object in order to get specific details. And finally, we can just create a Python dictionary in order to return the response. So now let's see how we can execute this script from our SDK client. So this is my SDK client. It's just a Linux instance. So this has some specific hierarchy for the directories. And from here, I can run my script like any other Python script. I need to pass my arguments, like for example, my input plan file, the source node, destination node, metric type, the traffic that I want to add to my demand, and the Crosswork Planning VM details. Once executed, it produces the dictionary with the attributes that I'm interested in, like for example, latency values, also the maximum interface utilization, and the routing path hop by hop for my new demand. So then in the next example, I will use another script, but this time using the design RPC API. So I will use exactly the same plan file, the US1 plan file. So the objective of this script is that it will run the simulation analysis tool in order to get the worst case traffic interface utilization and traffic. Main step is that we need to import the design API library. So next, let's focus only on the main structure. So basically, we start by reading our arguments, like the input plan file and Crosswork Planning VM details, and the failure types that we want to pass to the simulation analysis tool. So then, using the with statement, we first need to open the connection with the design service. In this case, it will be using the service connection manager, and then we need to access to the plan file using the plan manager, and then we access to the simulation tool using the tool manager. So this is all about managers. So next, we create a dictionary where we will read our failure types argument, and those options we will use to pass to the simulation analysis tool. In order to run the simulation analysis tool, we use the run operation, and we pass all the corresponding attributes. And finally, we will get a list of interfaces after the simulation analysis is executed. And then I will call a function that will do some post-processing of my values. Finally, I need to close the connection with the design service, again, using the service connection manager. So now let's execute this script through the SDK client. Again, I call my script, and I will pass the corresponding arguments. In this case, input plan file, Crosswork Planning VM details, and the failure types that I will pass to my simulation analysis tool. So then once executed, it will produce a dictionary with all the attributes that I am interested in this case, the interface with the maximum interface utilization, the utilization value, the interface with the highest traffic, and the corresponding traffic value. So far, we have seen 2 Python scripts returning some structured data dictionaries with attributes that I am interested in. But how to know which script I need to use and how to know how to use them. So we can add, for example, a help description. That is OK. That works. But But what happens if in a large network and in a very highly automated network, I may end up with tens or hundreds of scripts. So then using this help description maybe will not scale properly for us, for humans, right? So we may have also other challenges, like for example, rotation of personnel in our teams, new hires that will need to get some time in order to learn how to use cross-work planning, in order to use how to use the APIs, in order to create new tools or to understand existing code. So there are many challenges still associated with a network automation. And what are the opportunities we can see here? So we are today in a point where we can trust in the automation tools because, well, as we saw, they offer very powerful tools in order to automate actions, like, for example, cross-work planning, right? But now, with the adoption of the new AI tools, we are in a position also where we can begin to explore new options, the creation of autonomous and intelligent systems that can help us to take independent decisions. Even the simplest decisions, like for example, determine which tool or which function will better address our needs, and then run the tools with autonomy, and then provide to us, return to us only the information that we are interested in. So how can we introduce this kind of autonomy into our network operations, in our network automation, using agentic AI? And what are the key ingredients when we talk about agentic AI? We may think this is super complex, but it is not. Basic ingredients. We require Python in order to build the tools, and we know cross-work planning supports natively Python using the APIs. We require to have a digital map to provide context to the agent, and using a defined schema. This can be perfectly mapped with a cross-work planning network model. And then we require to have an LLM that will act as the brain of the agent. So this is all what we require basically. So now this is an example of how an agent can interact with cross-work planning. We rely on the deployment of the SDK client, and then inside the SDK, the agent will reside locally. The SDK will also have an external connection to the LLM. And then what are the components of my cross-work planning agent? We basically have, in this case, a custom web UI that the user will use to interact with my agent. We have the cross-work planning network models or plan files that are mapped to a defined schema. We have the tools or functions that will contain the functions that will use the cross-work planning APIs, Python APIs. And we have the prompts that will provide context and will describe all the available functions in my agent. And finally, we'll provide the agent identity. So let's focus on the functions, on the tools, and also the prompts. So in this case, you can see to the left side, we have an example of one function available in my agent. It is using the design RPC API. So here we don't really need to care about the input arguments because everything the agent will use is basically the function. So we don't really need to care about the main structure, for example. Then the LLM will be the one that will extract the variables from the user request and will pass to the function. So then the function will return an output that is in a structured format. It has something defined with some keys and some values, right? And then we have the prompt to the right side that will describe the function like if any human would be describing it. It is pure text, it is in a string format, but it still has also a structured format. Why? Because I want to share the context to the LLM without ambiguity. So I want to be the most clear as possible. So far we have talked about a structured format for the digital map, for the result returned by the function, even for the prompt. So why is a structured format so, why is it key? Why do we mention it so multiple times? Because we want to isolate the schema from the network data. We want to share with the LLM only the schema definition. We want the LLM to know where to find the values, but we don't really want to share the values with them. So that is why a structured format is important. So this is the proposed workflow for this example. So basically, the user will initiate the request through the web UI, custom web UI, using a natural language. And then the on-premise agent will be listening. Once he receives the request, he will start the interaction with the LLM. For this example, I use OpenAI, but you really can use any provider you want for the LLM. And then for this example, for this demo, I'm using a planning strategy that is called change of toes. That basically the LLM will return a plan with defined steps. So then the agent will receive the plan, and he needs to run step by step the plan. And if the user requested some simulation scenario, then one of the steps will be to use the Python functions that will use the Crosswork Planning APIs in order to run the simulation scenario. Then once the result is returned by the function, the agent will read the result and will extract only the information that the user requested. Once he formats the output, he will send back to the front end, to the web UI, and then it will show to the user. So now let's see the agent in action. So this is the custom UI for the agent. We basically need to upload the network model, the Crosswork Planning network model, and the agent will abstract this into a graph database. So then we can also review, for example, what is the schema definition in this case for our digital map. And now I will start with a basic question. Just tell me, for example, what is the total number of interfaces that I have in my network? This is very basic, and we know this doesn't really require any simulation. So the LLM will come back with a plan, and the first step in the plan in this case is, okay, I need to count all the nodes in my graph database that are of type interfaces. So then the agent will format the output and will show the output to the user, that in this case showing 100 interfaces. So for the next question, again, I will ask another basic question. Tell me the total number of routers in my network. So I send the query, then I wait for the plan, the agent waits for the plan. And the first step here is, again, okay, I need to count all the objects in my graph database that are of type node. So then format the output again, and then finally will show to the user. In this case, it will be 33 nodes. Now I will increase the complexity. So I will ask this time, okay, I want to know this time what would be the maximum interface traffic utilization in case of circuits and node failures. And I also need to know what is the interface name, the impacted interface name. So once I send the query, the LLM will come back with a plan. And let's see what is the first step. So in this case, the first step is, okay, I need to use the get worst case traffic utilization function. So once the response from the function is back, the agent will extract only the information requested by the user. And the information requested was actually only the maximum interface utilization after the failures and the corresponding interface name. That is everything that the user requested. So now, I would like to know what is the most impacted interface in case of failures of one specific node in Washington, D.C., and what would be the traffic value in Mbps. So now I send the query. The agent, again, will wait for the plan. And let's see what is the first step in the plan. So in this case, the first step is that, okay, I need to run a simulation of this specific node in Washington, D.C., and then I will determine what is the most impacted interface and its corresponding traffic value. So then again, the agent will extract the information based on the user request and will format the response, and finally will show the response, okay, this is the most impacted interface and its corresponding traffic value. So now I will ask a different question. Okay, I need to add a new demand between Chicago and Los Angeles, and I need to know what would be the maximum latency across the route. So let's see what is the first step in the plan now. So in this case, it says, okay, I need to prepare my arguments that I will pass to this specific function, get route shortest path. Okay, so next I will call the function. And once I get the results from the function, I will extract only what the user requested to me, that is the latency value. So next I format the output, and finally I show the output to the user, specifically what you requested only. So now, next question, I would like to know what would be the routing path if I add a new demand between New York and San Jose. So again, let's wait for the first step in the plan. Okay, so I need to run the get route shortest path function. and then I will extract my information and will transform it to show you, in this case, showing the hop-by-hop routing path for this specific demand. And last question, I would like to add a new demand between Seattle and Miami with 1 gig of traffic, and I want to know if I have enough capacity and also what would be the maximum interface utilization. Okay, hold on, I will come with a plan. So let's see the first step in the plan. Okay, so the first step is I need to prepare the arguments to run the get route shortest path function. Next, I will call the function itself. And the next step will be to extract the corresponding data that the user requested, and finally show the user, show the response to the user. In this case, it will show what is the maximum interface utilization, and the agent also did some analysis. It is saying to you, no, you don't have enough capacity because the maximum interface utilization would be 100%, 112%. So with that, let's go to the conclusion of this session. Few takeaways. Well, you can simplify your network design, your network planning and optimization using Crosswork Planning native tools. You can supercharge your network planning using the Crosswork Planning APIs, and it is very easy to use the APIs because they are high-level Pythonic. And if you want to scale decision-making and do the shift from automation to autonomy, then you can start using AI agents. So some resources you can take a look. If you missed, yesterday we had a workshop about the AI agents, but if you miss it, we can always schedule something on demand for you and your customers. Yeah, so, well, this is all about. Thank you.
Thank you, Julia. Any questions from the audience or from Slido?
I don't have it. Okay.